Hey guys, welcome to Pepcoding. Today we'll learn another question, Pepcoding course schedule. So basically here we have so many courses at Pepcoding, and there might be some courses which require something like you need to do some courses first. Like for example, if you are going to try for course number 2, but it requires you to complete you course number 0 and course number 1. Only then you can do course number 2. Okay. So suppose this is our question. So guys, the thing that I'm going to tell you is also known as Kahn's algorithm. So basically, suppose course number 0 and 1 does not require you to do anything. Course number 2 requires you to do course number 0 and 1. Course number 3 requires you to do course number 0. Course number 4 requires you to do course number 3. Course number 5 requires you to do course number 4 and course number 1. So guys, here this you can see this is a non-cyclic unidirectional graph. Okay, it is a directed graph and it's non-cyclic. So for Kahn's algorithm, we need this kind of graph. If the graph is bidirectional or if it is cyclic, then we can't perform Kahn's algorithm. So basically in Kahn's algorithm, we do a topological sort. So see, if you see in this, in degree of 0 is basically 0. It is not dependent on any of other vertex. Okay, similarly 1 is not dependent, 2 is dependent on 2 vertex, 3 is dependent on 1, that is 0, 4 is dependent on 3, so 1 dependency, 5 is dependent on 1 and 4, so 2 dependency. So it's in degree is calculated like this. Now in Kahn's algorithm, in topological order sort, what we are supposed to do is print all those whose in degree is 0, so that will be 0, 1. Then if 0 is printed, then I can go for 3, then I can go for 2, then for 4, then for 5. I required to do course number 0 to get to course number 3. I required to do course number 0 and 1 to get to course number 2. And I required to do course number 3 to get to 4 and 4 and 1 to 5. So this would be my answer. This would be the order, topological order. Let's understand it more by understanding complete Kahn's algorithm. So here, if I take a Q, first of all, let me find in degree of every vertex. Okay, first we'll do that. After finding, if I put all those elements whose in degree is 0 in my Q, so those will be 0 and 1. Okay, then what? Then I'll pop 0 and I'll put I'll go to all its neighbor and subtract its in degree by 1. So let me change the color. Let's say green. So here instead of 1 it would be now 0 and it would be 1. So since in degree of 3 is now 0, so I can add 3 here. So 3 is added. Then we pop 1. We go to its neighbor. So here when we come to 2, now the in degree is 0 and to 5 it would be 1. Okay. Since in degree of 2 is 0, I'll add it. Then I'll pop 3. I'll go to its neighbor. Its in degree becomes 0. I'll add 4. I'll pop 2. It has no neighbor. Then I'll pop 4. It has one neighbor. Its in degree will be 0. I'll add it. I'll push it. Then I'll pop 5 and print it. So see the order 0, 1, 3, 2, 4, 5. This was my answer. This was something I supposed to get. Now what if it is a cyclic graph? Suppose 4 is connected to 0. Here's a cycle in this graph. Now what will happen basically? The in degree of 0 won't be 0. It would be 1. Okay. And suppose 0 is connected to 1 also. Okay, here's the cycle detected. The graph is cyclic. When I start from 0, I can come back to 0 again. So in degree of 0 and 1, both would be 1. So I would never be able to achieve 0 first and 1 first. I won't be able to achieve any element because everyone is dependent on each other. Or suppose if it's bidirectional. If it's like this, let me undo this, changes. Suppose 0 is dependent on 3 and 3 is dependent on 0. So in degree of 0 would be 1. In degree of 1 would be also 1 here. So I can't print my answer. Okay. in degree is 1, then I can never get to the answer. Khan's algorithm will fail here. So in such cases, when I get such answers, I need to return -1. Okay, let's see the code. So first of all, we need in degree. So let's make an array called in degree, and its all value should be 0. Okay, then its size must be equal to num courses because we need these many vertices. So let's find in degree of each vertex. So I0, I less than num courses, I plus plus. For now, I need to traverse in the graph. Int neighbor in graph of I. Here I need to traverse. Now in degree of neighbor would be incremented. Okay. Now what? I'll make a queue. Okay. Queue of type int. I'll name it queue. Now I'll run the loop in degree and find if there are elements with 0 degree. So int I equals 0, I less than num courses I plus plus. Sorry. If my in degree of I is equal to 0, then q dot push I. Okay. Now while my queue is not empty, so q dot size is not equal to 0. Till then I'll pop out the element, then I'll put it in the answer. So answers something equal to rem. So where should I put it? So I need an index. So int idx equals 0 and here idx, and I need to increment my idx also. Okay, so now I'll subtract the in degree and check if it's 0, then I'll add it in the queue. So int I in graph rem, sorry, if in degree of neighbor, I'll first subtract, then I'll check if it's equal to 0, then q dot push neighbor. Okay, this is not I, this is neighbor. Yeah. Now what? Now need to check for validity. So if all the courses are traversed, that means that if my idx is equal to num courses, in that case it's a valid case, so I'll just print. I'll print all the elements of my answer. And I'll simply return. Else I'll print -1 and return. Let's see. The code must run. Okay, some error in line 18. Okay. This will work. Cool. Rejected. Q dot front Let's see. Line 21. Okay. Yeah, it is accepted. It was not working because of some pre-operation, pre-incrementation, decrementation. Due to that, it was not working, but now it is working. So I hope the Khan's algorithm is clear to you guys and the code is also clear. So please like, share and subscribe to Pepcoding. Thanks for watching.